Welcome to math class. In similar triangles, exercise 1, fifth problem. Prove that a line joining the midpoints of any two sides of a triangle is parallel to the third side. Use converse of basic proportionality theorem. If a line divides two sides of a triangle in the same ratio, then that line is parallel to the third side of triangle. We have to prove here line joining midpoints of two sides of triangle. Here AB, AC two sides, D is midpoint of AB, E is midpoint of AC. We have to prove DE is parallel to BC, and we have to use that converse of Thales theorem or converse of basic proportionality theorem. What is given, children? Given in triangle ABC, D is midpoint of AB, D is midpoint of AB, and E is midpoint, this point E is midpoint of AC, E is midpoint of AC. To prove, we require to prove this DE, this line DE is parallel to BC. Okay, see children, in that proof, D is we know D is midpoint of D is midpoint of AB. D is midpoint of AB means AD equal to DB. AD equal to DB. See here, AD by DB equal to 1 because AD equal to DB. So I am writing here DB by DB equal to 1. No? So AD by DB equal to 1. This is equation number 1. And also E, point E, E is midpoint of AC. E is midpoint of AC means AE equal to EC. AE equal to EC. Here AE by EC also we get 1. This is equation number 2. See children, from equation number 1 and 2, AD by DB equal to 1, AE by EC equal to 1. So here from equation number 1 and 2, okay, see here, from equation number 1 and 2, AD by DB equal to AE by EC. So AD by DB equal to 1, AE by EC equal to 1 means therefore AD by DB equal to AE by figure EC. DE is parallel to OQ and DF is parallel to OR. Show that EF is parallel to QR. Once all of you see children, here what is given? Given first of all DE is parallel to OQ and DF is parallel to OR. So first of all DE is parallel to OQ. Once you observe this figure, DE, this line, is parallel to OQ. These two parallels in triangle POQ. So let us consider in triangle POQ. And we have to divide like this. We have to decide like this. So మనకి ఇక్కడ DE లైన్ అండ్ OQ టూ ప్యారలల్ లైన్స్ అనేవి POQ ట్రయాంగిల్ ఉన్నాయి కాబట్టి మనం ఇక్కడ POQ ని కన్సిడర్ చేసినాం. సో ఇన్ ట్రయాంగిల్ POQ DE is parallel to OR. DE line is parallel to OQ. Sorry, DE is parallel to OQ means by BPT theorem we can write PE by EQ equal to PD by DO. PE by EQ, PO by PD by DO. PD by DO. This is equation number 1. And next what is given? And next DF is parallel to OR. DF line. Here two arrows are appearing now. So DF, this line DF is parallel to OR. See, DF and OR parallel sides in triangle POR. So next, in triangle POR, DF is parallel to OR. DF is parallel to OR. Here use Converse, basic proportionality theorem. PD by DO equal to, we can write PF by FR. This is equation number 2. So here in triangle POR, DF is parallel to OR, PD by DO equal to PF by FR. See, once you observe equation number 1 and 2, PE by EQ equal to PD by DO, PD by DO equal to PF by FR. So from equation number 1 and 2, here PD by DO equal to, this is also PD by DO equal to. So here we can write PE by EQ equal to PF by FR. PE by EQ equal to PF by FR. Once you observe PE by EQ, PE by EQ equal to PF by FR. Here PQ and PR sides, EF line, the two sides divide in the same ratio. So we can say EF is parallel to QR by converse of basic proportionality theorem. So PE by EQ equal to PF by FR means we can write EF is parallel to QR since by CBPT, converse of basic proportionality theorem. Here we are proved. Here we are asking here, show that EF is parallel to QR. No. So EF is parallel to QR. What is the reason? Since in triangle PQR, in triangle PQR, PE by EQ equal to PF by FR. By Thales theorem, converse of Thales theorem, we can write EF is parallel to QR. Okay, thank you.